Every photo that has ever been taken and every photo that ever could be taken is a sample of a single function. A photo is a 2D sample, a video is a 3D sample, and a stereo, like your eyes, is two 2D samples right next to each other. This function was first found by Adelson and Bergen in 1991. They were vision scientists, not computer scientists. They were trying to understand what our eyes see before information gets to our brain. Okay, here's how you build it. Stand anywhere in space. That's 3 numbers. A position. Look in any direction. That's 2 more numbers. An angle. So far you have captured 5 dimensions. 3 to introduce position and 2 to introduce angle of the picture that you're looking at. Pick a wavelength of light. That's 1 more parameter. Pick a moment in time. That's another parameter. So that's 7 numbers in, and the function returns just 1 value. The intensity of light arriving at that point from that direction, at that wavelength, at that instant. Now here comes one genuinely clever way of reducing parameters. In an empty space along a straight ray, radiance doesn't change. The light leaving a surface and is the same light arriving at your eye 2 meters away. Same value. So if only you care about the regions outside an object, one of the 5 dimensions is redundant. Any point along the ray gives you the same answer. So what matters is the ray, not the point. So in this case, you're just making a database of rays. All you care about is the position and direction of those rays coming to your eye. So you need 2 planes to index each ray. 2 coordinates on the first plane and 2 coordinates on the second plane shows the position and direction of each ray. The 4D parameter reduction only holds in empty space. It's valid outside the scene, looking in, a camera orbiting an object staying beyond this convex hull. But the moment you want to move through a scene, between objects, behind occluders, ray gets interrupted. Radiance is no longer constant along them, and you need the full 5D function back. That's the density. Position and direction in, color and density out. That is literally the function NERF learns. NERF isn't some exotic new object, that's the Plenoptic function, with the free space shortcut remove and occlusion handled by volume rendering. So when you have a differentiable function, you can easily use descent to find the optimized points. So you can go from an implicit function to an explicit function. So you initialize the points and then you add these fuzzy Gaussian blobs on it and optimize that. And that's how this research field went back and forth through the years. Back in 1996, we were using explicit database of rays to reconstruct scenes, but we were very limited. Then we got to NERFs that were very implicit, and then we went back to explicit representations. The thing we learned was differentiability is the key to 3D reconstruction. In 2025, we asked ourselves, can we have triangle primitives? The good thing about it is that if you want to reconstruct in a straight line, let's say edge, you just need 1 triangle to represent it. But on the other hand, if you're just trying to do it with Gaussians, you need a bunch of small Gaussians in a row to do it. But the problem is the triangle is the worst possible shape for gradient descent. The answer to this is apply a smooth window function over the face with sharpness parameter. Turn down the triangle render as a soft blob, nearly Gaussian-like, and gradient flows everywhere. Turn up it and approach to a hard edge opaque triangle. So a triangle in this system isn't one thing. It's a dial between a splat and surface. Early training, everything is soft and mobile. Geometry slides around freely. Usually when you hear triangles, you're imagining a mesh. But it's not a mesh. It's a triangle soup. Disconnected, unordered, mutually overlapping, semi-transparent triangles. No shared vertices, no connectivity, no manifold structure, no inside or outside. Extracting a genuine connected surface from those outputs is open, and it's hard. It's one of the problems that researchers are actively working on.